Welcome to geometry. This isn't the geometry you had in high school where you had to do proofs and worked with conic functions and such. This is just really the basic stuff. Looking at perimeter, area, and volume of common shapes. We'll start off with squares, rectangles, triangles, and then move on to circles later on in the video. Okay, the perimeter is the outside edge of a shape, the length of that outside edge. It is something you can walk. When you hear about somebody walking the perimeter, they're walking around the outside edge of the camp. It is measured in length. Units are important in this situation because units will tell you exactly what you need to do. Okay? We get it by adding side 1 plus side 2 plus side 3 plus however many sides there are. So if it's a triangle, you only add 3 sides. If it's a square, you add 4. If it's an octagon, you add 8. Whatever. I use a expensive and sophisticated visual aid here. The perimeter is the outside edge. So we add the lengths of these 4 sides. The area. Area is something that you can paint. Its units are length squared. And you get it by multiplying the base times the height. Okay? Visual aid time again. The area is the face of the box. We multiply the base times the height. Okay, sometimes I'm a little sloppy with which is base and which is height because you know what? It doesn't matter. It could be base times height, it could be base times height. The area of the face does not change with changing the orientation. Okay, so base, height. The volume. Volume is something you fill. Its units are lengths cubed. You get it by multiplying the area times the length, or the width, or whatever you want to call it, the third dimension. All right? The volume is how much fits in this box. Okay? More will fit in if one of these dimensions is bigger. Okay? It is the area that we found before on the face, times the height of the box, the width of the box, the length of the box, whatever. It's length this way. Doesn't matter which number is which as long as they're all multiplied together. So for a rectangle, that is base, height, length, or width, or whatever. It's just the 3 numbers multiplied. Okay? Let's do some examples. Once again, we're using the word problems booklet here. G1 number 1. How many meters of fence will Bell Pepper need to buy to fence in a triangular piece of land for a vegetable garden if the sides measure 33, 44, and 55 meters? Okay? 33, 44, and 55. With geometry, you can usually work better with the problem if you draw a picture. Doesn't have to be a complex picture, but if we draw a picture. In this case, we've got the garden. We're going to put in a fence. That means we're going to do the perimeter. We're going to go around. We're not going to fill in the garden with a fence. Okay? So we just add 33, 44, and 55. Okay? This is 12. So this is 13, 132 meters of fence. G1 number 4. Mrs. Cook's kitchen is 16 feet long. If the width is 3/4 the length, how many square feet of floor space does she have? Okay, so here's the kitchen. It is 16 feet. This is 3/4 of 16. We're combining our fractions in with our geometry. Well, 3/4 of 16. 1/4 of 16 is 4. So 3/4 of 16 is 12. So we've got 12. So now we have to multiply. We're looking for the area. So we're looking for this section here. We can multiply these two together to get the area. 16 times 12. 2 times 6 is 12. 2, 3, 0, 16. 192 square feet is our answer. G1 number 2. Salman bought an ice chest for an overnight fishing trip. If the ice chest is 4 feet long, 2.5 feet wide, and 18 inches high, how many cubic feet of ice will it hold? Okay, so 4 feet long, 2.5 feet wide, and 18 inches tall. There we go. Here's the trick. Because this is just multiplying together, they throw in all sorts of other stuff from other units. We saw fractions in the last problem. Now we see conversions. You gotta watch the units. Watch them carefully. Because this is 18 inches. That's 1.5 feet. If we use 18 instead of 1.5, we'd get a much bigger answer. So, first thing you do is you check the units to make sure that they're the same. And if they're not, you make them the same. So instead of 18 inches, we're going to make this 1.5 feet. Otherwise, it'll be screwed up. Okay? What we're going to be doing is, when we do these, we have to multiply the units as well as the numbers. So 2.5 times 4 is 10. But this is feet, and this is feet, so this is feet squared. Okay, at this point what we have is the area of the base. The area of the top or bottom of the ice chest. Now we have to multiply it by 1.5. Okay, 15 feet cubed. All right. I want to show you how those units can help you figure out what you're going to be doing. Okay, let's look at some of the answers in this book. All right. So we see meters, that tells us we're doing perimeter. We see cubic feet, that tells us we're doing volume. We've got square feet, that tells us we're doing area. So by looking at the answers, the units on the answers, that tells you whether you're adding, multiplying, or multiplying 3 numbers. Okay. G1 number 7. Enclosed wants to fence in a run for his dog. The area he will fence is 8.5 feet by 14 feet. How many feet of chain link fence does he need to buy? Okay. So the answers are in feet. That tells us we're adding. And perimeter. We're going around the outside. We're not going to fill in the dog run with fence. The dog wouldn't have anywhere to go. So it's 8.5 times 14. Because we have a run that is 8.5 by 14. not drawn to scale. But in these you don't have to. You just have to have an idea. Okay? So, let's do it. 10 times 8.5 is 85. So we have to have 8.5 times 4. This is 32. And then half of 4 is 2. So it's 34. 85 plus 34 is 119. 119 feet. G1 number 9. The perimeter of connoisseur's dining room is 45 feet. If the length is 12.5 feet, what is the width? Okay. So we have the dining room. All the way around is 45 feet. This is 12.5 feet. They want to know what this is. So when we're doing a perimeter problem, we're adding the 4 sides. In this side, in case we have x. So we got 2 12.5s and 2 x's. So we have 45 equals 2x plus 2 times 12.5. All right, this is 25. So 45 equals 2x plus 25. We subtract 25 from both sides. 20 equals 2x. Divide by 2, we get x is 10 feet. A square stamp measures 5 centimeters on a side. If the stamp is enlarged by 3 centimeters per side, how many square centimeters are added to the area? Okay, so we've got a stamp that is 5 centimeters on a side. Anytime you see the word square, they only give you one number. That's because the number is the same on all sides. We're adding 3 centimeters to a side. Okay? And they want to know how much area is added. How much is that? We might be tempted to say, hey, 3 times 3 is 9, so 9 is added, right? But 9 is only this section here. We need to add the whole thing. So the area of the stamp originally was 25. 5 times 5. After we add the 3, it's 8 times 8, so that's 64. Okay? 64 minus 25 is 39. So 39 inches square inches were added, which is bigger than the stamp was itself to start with. Okay, let's look to see find those. Okay, we said 3 times 3 here is 9. Here we got 3 times 5. This is box is 3 times 5. So that's 15. And here's another 15. 15 and 15 is 30 plus 9 is 39. And that's what we got here. Okay? Okay, G1 number 12. At $6.95 a square yard, how much will it cost to carpet the den, which measures 15 feet by 21 feet? Okay? $6.95 per square yard. And we've got a den that measures 15 by 21. Okay, we check the units. This is per square yard. This is per square foot. This will give us square feet. So we need to make the conversion. It's easiest to make the conversion before you do the multiplication. Okay? So we divide all these by 3 because there's 3 feet in a yard. So the room is 7 yards by 5 yards, which gives us 35 yards. All right, 35 yards. I'm going to say this is $7 a yard because I don't want to multiply $6.95. 35 times 7 is 21. $245. So because this was a little under 7, the answer will be a little under $245. If you want the exact answer, we can say, hey, $6.95 is $7 minus 5 cents. So the actual answer is $244.65. Okay? What happens if you don't recognize that you need to change units until after you've done the multiplication? Do you need to throw out all that work? No, actually you don't. You need to make the conversion after you do the multiplication. Okay? So we had 15 by 21. All right, 210. 220 and a half. 21 times 15. 5, 10. 315. Okay, there's 315 feet squared. But then we go, oh crap, we need to get yards. Well, there is a conversion factor. All right? 1 yard is 3 feet. If we square both sides, we get 1 yard squared equals 9 feet squared. So in this case, we need to divide this 315 by 9. Not really a nice number. I think it's probably easier just to throw it out and divide by 3 and go back. But this is an important idea here. If we have 1 yard on 1 yard by 1 yard, that's 1 square yard. Each yard is 3 feet. So 1 foot, 1 foot, 1 foot, 1 foot, 1 foot, 1 foot. It's 9. Okay? Because you're not just multiplying this way, you're multiplying this way as well. So you're going 2 dimensions. If it's volume, it's cubed. It's 3 dimensions. Okay? So that's where this conversion factor comes from. I remember a question on a test that said something along the lines of the front yard is 15 by 25 and the backyard is 30 by 50. What is the ratio? The answer is 4 to 1 because there's going to be 4 because the 30 is 15 twice and the 50 is 25 twice. So the answer is 4 to 1, where most people will just jump to 2 to 1. Okay, the units that we're dealing with don't necessarily always have to be standard units. For example, we've got a problem here that says G2 number 6. The Nelsons are covering a 16 by 28 foot patio with 2 foot square blocks. So we got 16 by 28 feet. The blocks are 2 feet square. So 8 blocks fit this way. 14 blocks fit this way. Because each one is 2 feet on the side. So we're multiplying 8 blocks by 14 blocks. We have 112 blocks. Okay, by changing the units before we do the multiplication, we simplify the numbers that we're working with, and then we don't get tangled up at the end. Okay, so look at the question, read it carefully and see what it's asking for. In this case, it said how many blocks. So that means we have to find blocks. Find the blocks before you do the math. Okay, let's talk about circles. In general, if you're doing a test and you're really short on time and you see the words radius or diameter, guess. Because circle problems take longer. All right? Well, let's look at these. Perimeter. For circles, the perimeter is called the circumference. I don't know why it has a different name, but it does. Okay? The circumference is the length of the outside. If you were drawing a circle with a string, how long would the string have to be? Okay? That is 2 pi r or pi d, where the d is the diameter of the circle, which goes all the way across, and the r is the radius, which is the center to the edge of the circle. Okay? Pi was determined by seeing how many times it would take to lay the diameter on the circle. It goes 3.14159 ... times on there. Okay? That's why we're stuck with such a weird number. Generally, we go with pi equals 3.14 or 22/7. At 22/7 can help if you're multiplying pi by something that has 7 in it. All right? Area is pi r squared. Okay, I like to remember this version and this together because they both have a 2, a pi, and an r. Okay? And you know that perimeter, or circumference in this case, is a single length unit. So r is to a power of 1. The 2 has to be in front there. Area, you have to have a distance squared. That means the 2 has to be on the r. So that way I remember one set of numbers, one set of letters for both of them. And just figure out where the 2 goes. All right, the volume. In this case, we're looking at volume of cylinders. Okay? Once again, the expensive and sophisticated visual aid. Here we've got our diameter and our radius. We find the area of this circle and we multiply it by the height. Okay? That'll give us the volume of this cylinder. Volume times height. Sometimes it says length. Length is just if we turn the cylinder sideways. For example, if we're dealing with a tanker truck, it's sideways. If we're dealing with a round swimming pool, it's vertical. But whether it's height or length, it's that one times the area of the circle. All right. Let's look at a problem. G1 number 11. Private Eagle, an observer, can see 5 miles in all directions. What is the area he can see? So here he is sitting there in his tower, and he can see 5 miles in all directions, no matter which direction he turns. That's a circle. because with a radius of 5. Okay? So we're looking for area. Area equals pi r squared. So it's pi times 5 squared. That is 25 times pi. Okay, you can multiply this out. However, there are faster ways. Okay? First, $25 times 3 is 75. So we're looking for something a little over 75. So we can check the answers and see if they are far enough apart that that will work. We have 25 square miles, 78.5 square miles, 125 square miles, and 15.7 square miles. So 78.5 is a little bit over 75. There's our answer. We don't need to do the whole thing. If the answers were close together, and we did need to do the whole thing, one thing that I came up with recently is that 0.14 on pi can be done with the 10% method. Okay? 0.14 is 14%. That is the same as 10 plus 5 minus 1. Okay? 10% of 25 is 2.5. 5% is half of that. 1.25. So we get 3.75. Minus 1%. We just move that decimal over again. 3.5. 3.5 plus 75 gives us our 78.5 that the answer was. Okay? G2 number 2. How much will it cost to resurface the bottom of a circular swimming tank that has a diameter of 28 feet if resurfacing costs $1.25 a foot? So, the diameter is 28 feet. That makes the radius 14 feet. It costs $1.25 per foot. So that's what we have from the problem. So now let's look at that. The area is pi r squared. Okay? Pi times 14 squared. I know that there's a 7 in there. And I know I want to pull that 7 out so I can use that 22 over 7. Okay, 14 squared is 7 times 2 times 14. Okay? 14 squared is 14 times 14. I broke one of those 14s up so that I could cancel this. So now we have 22. 2 times 14 is 28. 22 times 28. 28 times 2 is 56. So we have 560 plus 56 is 616. Then we're times 1.25. 616 divided by 4 is 1, 5, 4. 154 plus 616 gives us $770. G2 number 3. Sergeant Truss is reinforcing a barrel which has a 1.5 foot diameter with a metal strip. He allows 3.5 inches for overlap. What length does the metal strip need to be? So, we've got a barrel, 1.5 feet. we're going to go all the way around it and have a 3.5 inch overlap to hold it in tight. So 1.5 feet is 18 inches. Because we want to work with whole numbers if we can. Okay? Circumference is pi d, 2 pi r. That gives us pi times 18. Okay, 18 times 3. That's 20 times 3, which is 60, minus 6. So that's 54 inches. Now we have to do the 18 times 0.14, 14% of 18. So 10% is 1.8. 5% is 0.9, so we have 2.7. Minus 1%, which is 0.18. So 2.52. We add that onto this. And we get the circumference is 56.52 inches. Now we have to add this 3.5 inches. Okay, 56.5, I'm going to round to 5, plus 3.5 inches gives us an even 60 inches, which is 5 feet. And that's the answer we're looking for. This is the end of the lectures for the FAST class. I'm including a bonus video of test taking strategies where I can pass on some stuff like that to you. Good luck on your ASVAB.